All right, so what we're going to do here is follow up on the previous video. And in the previous video, we ended up with this gigantic plot like this graph. Um, I will say I just recorded this video and it was like half an hour and then it didn't save. So I'm re-recording and hopefully this will be a more efficient version of the video. So hopefully that'll be good for you all. So one of the first things to note about this visual that we ended up with in the last video was that there is so much information in here, right? There's so much data that it's hard to figure out what the purpose, not the purpose, but it's hard to figure out what this is telling us, right? There's some new words down here that I'll just kind of quickly introduce. When we are making a plot of some data, oftentimes a word that we hear is a trend line, right? A trend line, like these, we'll get to those later. I don't want to see that yet. I wonder why that's showing. I don't want to show that yet. Show that later. So here we go. Right. So a trend line is like a line that shows a trend. Okay. And a trend in words could be something like this. So as one variable increases in value, another variable will increase or decrease in value because it depends on the first value. On the first variable. Change that. Depends on the first variable. Oops. Okay. And then similarly, as one variable decreases in value, another variable could increase or decrease in value because that second variable depends on the first variable. Okay. And so this is where that term dependent comes from, right? A dependent variable is something that depends on another variable. And it will depend on an independent variable. Okay. An independent variable, I think about how it's called independent. I think about how it is independent of whatever the dependent variable value is. It's sort of like saying, like, you are either a dependent of someone, right? You are dependent on your parents, on your guardians, right? Maybe on some siblings to drive you around to different places. You're dependent on them, right? Whatever they decide to do, you have to go with it, right? They are the ones who are independent, right? What you do doesn't affect what they do necessarily. Sometimes it does, right? But they are choosing then to go along with what you want. So, like, if you ask your parents, like, hey, can we go to the store right now? Right? They're not doing something, they're sort of dependent on you, but it's more that like they are independently choosing to go, right? You are still dependent on whatever they choose. So in that case, like, they are the ones who are independent. They're the ones who decide, like, sort of a weird analogy. They decide what happens. You are dependent on that. If we're talking about data, right? One type of data might be something that you could change, like, independently. Like, you can change it. Just because it changes doesn't mean it's not independent. Like, if it's something that you can change sort of on your own, like, you change what type of mask you have, right? You're not going to choose the type of mask dependent on something else, generally speaking. You still have the ability to choose whatever you want for the type of mask. And the distance from the mirror, like, you decide what your distance will be, right? You decide if you're going to measure at 4 inches from the mirror or 2 inches from the mirror or 1 inch from the mirror. That's your decision. So that's an independent variable. But the dependent variable, like, that means that whatever that value is, it's dependent on one of the independent variables. So the layers of fabric in a mask is dependent on what type of mask it is, right? If it's a cloth mask, if it's like a 1-layer cloth mask, that's a type of mask, I would say, then there's 1 layer of fabric. If it's a 2-layer cloth mask, there's 2 layers of fabric. If it's a towel, there's 1 layer of fabric. If it's a sweatshirt material, if it's 1 layer of fabric. If it's a folded bandana, then maybe it's going to be 2 or 3 or 4 layers of fabric, right? But the layers of fabric, like, I don't know, it's a little bit tricky. You could intentionally make the layers of fabric to be what you want. So you could make layers of fabric an independent variable, and then maybe the diameter of the breath mark could be dependent on how many layers of fabric you choose to use. Or layers of fabric could be dependent if you are saying that type of mask, like you choose a type of mask and the layers of fabric depends on what type of mask you choose, right? So I guess what we could do here is we could add in some options, right? So like layer fabric could be independent or dependent. So I'll make a little an asterisk. And let's leave it there for now. So at this point, we've covered like what a trend is. We talked about that a little bit. But then when we dive into what a trend really is, that's when we're comparing 2 variables. So there's an X and a Y value. One of them is independent, one of them is dependent, right? As the independent variable changes, the dependent variable changes in response. As the independent variable changes in a certain way, dependent variable changes in response in a certain way. Okay, so maybe sort of like a general thing, general statement. Patterns are a little bit different. I think it'll make more sense when we get to it later. And a trend line equation, when we think about a trend line is a line, it's linear. So we can use a y equals mx plus b format to describe it. And this should be familiar from math class, right? Y and x are positions on an axis, along an axis, the x-axis or the y-axis, and m would be the slope of that line. So this can be a positive slope or a negative slope. B is the y-intercept. In this case, we're not going to be using the y-intercept for much. We're going to focus mostly on slope. But let's dive into how to unpack this, because this is a behemoth. This is a really big chunk of data. As I mentioned in the last video, actually, I'm going to pause for a sec to make sure that this video doesn't get deleted. All right, it worked. Video did not get deleted. We'll keep going. In the last video, we looked at how this graphical representation has 4 bars that point upward. Okay, whenever there's a bar that points upward, that means that it is it's being measured along the y-axis. And anything measured along the y-axis is usually considered to be a dependent variable. So maybe I'll change that over here. I'm going to put this right there. Put that right there. Dependent variables shown on y-axis. Maybe instead of shown, I'll say represented on y-axis. And independent variables are represented on x-axis, on the x-axis. So if we look at these, supposedly all of these variables, these 4 variables, are dependent variables because they're all being measured on the y-axis according to Google Sheets, right? But the distance of face from the mirror is under your control. That doesn't mean it's a controlled variable, right? Small like distinction. A controlled variable is something that doesn't really change. You keep it constant. So like temperature in this case is a controlled variable in this set of data. In this case, what I mean though is that like you have control over what the values of this distance are. So this is an independent variable. But so we need to take this out of being measured along the y-axis. So rather than take all of this stuff out, maybe here we go. Let's just actually take some of it out. So if you go to edit chart, you'll notice that when you are in the setup section, there are a couple different types of, there's lots of different kinds of charts you could use. Okay, eventually we are going to choose a scatter plot, but for now we've been using this column chart, so I'm just going to finish this next couple things using a column chart, and then we'll switch over. All of these allow you to represent the same data, the same observations and measurements, but a chart or a graph is just a visualization, so you can visualize data in many ways. Our trick now is figuring out what are the best ways that make the most sense. Okay, so down here, I can identify series, or dependent variables are often, they're called series in Google Sheets. Okay, and so what we need to do, we realize the temperature is not a series, it's a controlled variable. So we have to get rid of that, so remove. You'll notice that the green bars go away instantly. Okay, can I undo that? Yeah. So here you see that if I want to get rid of the green bars, come on back. The green bars represent temperature. So if I go over here and remove, my green bars go away. It looks like all of these other bars got bigger, but really they're being measured. They're the same size. If I undo that, look at this scale on the y-axis, right? The yellow still only goes up to 5. The green goes to 25. So what's happening is that when I take away these data points, the y scale automatically changes. So instead of going from 0 to 5 in this distance, it will go from 0 to 5 up here. That'll help you see more effectively the changes, the differences between these different columns. So remove. Okay. And what next? So now I want to only have 2 variables being compared. And so how many variables do I have? I have 1, 2, 3. Layers of fabric, distance of face from the mirror, diameter of breath mark, and I have type of facial covering. So I actually have 4 variables here. So I need to get rid of 2 more variables somehow. Okay. So I do need something on the x-axis. So then let's say I leave type of mask, right? I could get rid of layers of fabric. You know, if I'm trying to figure out like what makes the most sense to leave, this whole investigation is about trying to understand how masks affect how likely it is for the coronavirus to spread, or how effective masks are. And so we really need this diameter of the breath mark. We need that data to be in there. If that data is not in there, then, I mean, this is what really tells us what's happening with our breath. We don't have any other data that describes our breath except for that. So that has to stay. So why don't we just get rid of these for now? Okay. Maybe we can use them again later. Okay. So now, oh boy. Okay, so we have type of facial covering. And on the y-axis, supposedly we still have diameter breath mark. This is like so hard to follow. The thing about the way we have this set up though is, let's go back to our definition of a trend. A trend says that as one variable increases or decreases in value, another variable should also increase or decrease in value. Or in general, as the independent variable changes, the dependent variable changes in response. So if we look at the x-axis, there's no numbers here, right? There is no increasing or decreasing along the x-axis. If that's confusing, I recommend that you pause this video and think about that for a sec. There's no increase or decrease. It looks like there is because we have increase and decrease in the y direction, but in the x direction, there is no numerical scale here, right? You're probably used to seeing that this bottom line on a graph is always the x-axis with 0 to whatever, 10, 20, 100, 5,000. The numbers increase to the right. In this case, there are no numbers on the x-axis. And so we cannot establish a trend line that has a slope because there's no way to count from left to right. Like there is no left to right, really. All of these left to right positions are pretty arbitrary. They're just in this order because that's the order our rows were entered in, right? Like that data and that data and that data literally are that point and then that point and that point. If I were to reorganize this, let's say, and I were to make this 5 and this 2.5, then this graphing system doesn't care what order those bars are in. They just are showing what's here in the order it's typed in. Okay, so that's important to keep in mind. I just undid that in case you're wondering how it happened so fast. So what we need to do is we need to make sure that our x-axis has something numerical on it. So let's think about, maybe instead of type of facial covering, if we're saying it, well, let me back up. Instead of type of facial covering being a variable, why don't we make that a constant? What I mean is, if we focus only on this data, so the diameter of breath mark data, but for one type of mask and not 3, then let's say I just highlight this data and then I go to insert chart. What you probably notice is that these 3 bars are just these 3 bars right here. Okay, I could do the same thing with this data, which are the next 3 bars. And I could say insert chart. Okay, and then these 3 bars are the same as these 3 bars. And if I were to name these, right, I could name this chart something like no mask, right? I'm going to want a better title later that describes the variables present. But for now, this is helping me keep in mind what I'm looking at. Okay. And if I want, I could do that again for the filtered cloth mask as well. There we go. Filtered cloth mask. Okay, and so now you might be asking yourself, oh, and there we go. 1, 2, 3. 1, 2, 3. So what I just did was I took this data and I broke it out into 3 separate graphs. Now, you might be asking yourself, we're done now, right? We have 3 graphs. Like, well, no, they need to be scatter plots. So let's make them into scatter plots. Okay, so go to chart type, scroll down, click on scatter plot. Okay, do the same thing over here. Go over here, edit chart, scatter plot. And what you probably notice is that if I just gonna undo and redo, you might hopefully notice now, the place where the dot goes is the top of the bar, is where the top of the bar is. So just in case you had never known that before, 2.5, 5, and 5. 2.5, 5, and 5. Okay. So now, see it over here. Okay. So the problem that we still have, or one problem we still have, is that we still don't have any values along the x-axis. So we need to figure out, like, we need to find a, hold on. We need to find a x variable. So we need to find an independent variable that would be meaningful to compare to the diameter of the breath mark. And so a sentence frame that you might find helpful is this. How does blank affect, we can close this. Oh. So this is a really common way to ask a scientific question that you're trying to maybe test, right? How does one variable affect another variable? How does blank affect blank? So just try taking some of these variables. Maybe try taking some of these variables right now and kind of plug them into this sentence and just say them out loud to yourself. Okay, pause and do that. Where you say, like, how does the layers of fabric affect the distance from the mirror? And then ask yourself, does that make sense? Does the layer of fabric in the cloth affect the distance from the mirror? Not really. So, okay, we thought through that. What about how does the type of mask affect the layers of fabric? That could sort of make sense, right? The type of mask, the layers of fabric probably depends on the type of mask that we have. So that could make sense, independent and dependent, right? But again, we run back to that problem where type of mask is not quantitative. There's no number scale. And we're not yet including this really key dependent variable. So that's not the comparison that we want to have. But what if we say, how does something else affect the diameter of the breath mark? Right? What were we changing to really test? What were we testing, right? We were testing the distance from the mirror. We were also testing the type of mask. Okay, so I'm not trying to discount that, but I'll show you what we do with that in a little bit. So we're testing to see how the distance of the face from the mirror affects the diameter of the breath mark. So I need to update this label. This is not descriptive enough. Of face from the mirror. Okay. So I'm just going to update this so that I keep myself organized. How does the distance of my face from the mirror affect the diameter of the breath mark? I'll say my breath mark because it was mine. Okay. And if I write that now, so now I have an idea about what I'm trying to compare, right? Eventually, this kind of data, if I can successfully answer this question, how does the distance of my face from the mirror affect the diameter of my breath mark? Then I'll be able to use that in an evidence-based claim. I might say, well, as I get closer to the mirror, then the diameter blank does blank. Okay. But so what we need to do now is we need to add this independent variable, distance of my face from the mirror. We need to add that onto the x-axis. So let's go back to the chart editor. And in the setup section, we've described part of the data range already. We've described the series, but we need to add in the x-axis. So click right here, select the data range, and then go over here. So this is distance of face from the mirror. And these were our two dependent values, 2.5, 5, and 5. So I want to choose the x values that directly correspond to those. So the x values that were part of the same trials. And then, okay. Now let's go back. Now I have these numbers along the bottom. Okay, I don't have a label yet, so I need to go to my editor and go to customize chart and axis titles. And then we have a chart title, we have a vertical axis title, but we don't have a horizontal axis title. So let's add that in. Distance of face from mirror. You might have to type it, but I had already typed it. Let's see. Now we have it in there. Okay, so now we need to find a trend line. You might be able to see or describe yourself as you go to the right. It kind of looks like, okay, 5, 5, 2.5. So it kind of looks like as you go to the right, the Y value goes down. So we should expect to see the trend line kind of in this like downward sloping direction. So let's go back to chart editor, go to series, customize, series. Scroll down because we're describing something about the series, right? About this Y value that's being plotted. So we want to add a trend line for that series. And you could change the opacity, so how dark the line is. We can change how thick the line is, what color it is, right? It's up to you. But now we have this line. And back in the editor, you can scroll down a little bit more and go to label, show, use equation. So when we do that, now we're able to see our format here, y equals mx plus b. So y is the position of the blue dot along here. So 5 equals that if you have the x of 1. 5 equals that if you have the x of 2. Not exactly. So actually we should clarify. 5 would not equal that with an x of 1. This point would equal the y value, so like 4.5-ish, if x equaled 2. We're not going to go super deep into the math right now. The big idea is just to see that this is a negative slope. Negative slope means that as you go to the right, then your y value is going to decrease. So you have a positive change in x and negative change in y, leading you to this negative slope. So then what does a negative slope mean? We're so close, right? What does a negative slope mean? It means that when we go back to our title here and we're trying to describe this, we can say, how does the distance of my face from the mirror affect the diameter of my breath mark? Well, let's rewrite this. So I'm still going to keep independent variable first, dependent variable second. Okay, and I'm going to use this sentence frame down here. So as the distance of my face from the mirror increases, right, moves to the right, what happens to the dependent variable? The diameter of my breath mark does what? As I'm increasing to the right, diameter of the breath mark goes down. So the diameter decreases, gets smaller, right? So at this point, I now have a lot of information actually in this really pretty simple plot. So this is a scatter plot. This would be fully proficient for one of the required scatter plots that you need for this assignment. So at this point, you need 2 more scatter plots, right? So you could repeat the process you just went through and make 2 separate additional plots, one for the cloth mask, just like this, one for the filtered cloth mask, in addition to the no mask. But I want to show you something here. Rather than make 3 different plots, if you make 3 different plots, then it's still possible to compare each plot to each other, right? because one layer of analysis of this data, at least right here, like you could draw a conclusion from this data. You should have more data to draw a really strong conclusion, but you get a basic conclusion that as I get further away from the mirror, my fog mark gets smaller. Okay. First, just before we move on, just notice for yourself again, like, does that sound elegant to you? Does it sound like simple enough to explain what you observed without overcomplicating things? Because oftentimes the simpler results tend to be the more accurate ones. Not always, but sometimes. Definitely the case. So we can compare these two variables in this graph, but we are not yet comparing no mask to cloth mask to filtered cloth mask. So if we want to have this second layer of comparison, we would need to see and ask ourselves, is there a way to plot this and this on this plot the same way we saw, when we first had that really behemoth chart, if we select everything at once and we make this, right? We could have this, something like this. But again, this is not useful yet because of reasons we already talked about. There's too much going on. Some of the data is represented in the wrong place. Some of it shouldn't even be on here. But this is a more compact representation, and it's more complex, but it's more compact and it can say more. So if there's a way to include multiple different comparisons on one scatter plot, that can be powerful. So I want to show you how to do that. Okay. Sorry that there's stuff just keeps moving around. What we're going to do is we're going to take the cloth mask data and try and get it onto this graph. So basically, instead of having those three columns next to these three columns, I'm going to try and overlay them. So put these three like essentially sort of on top of here, and I'll show you what that means. So let's go back to my chart editor for this main chart. Let's look at what the x-axis should be, right? The distance of face from the mirror, that's always going to be our x-axis for these three comparisons. We have the same x-axis, the same independent variable. And what's really cool for this comparison is that we have the same three values, at least in this data set. Your data set might not have this, so this might be more challenging to set this up like this. But what you could do is say, okay, I know that these two dependent variables, these two examples, I guess you could say, no mask and cloth mask. They're both using the same x and y variables. So when we're in the chart editor, we should be able to recognize, okay, x-axis, or we can recognize, I should say, x-axis E4 to E6 is right here. E4 to E6. Okay, 421. If I were to highlight 421, like down here for the cloth mask, those are the same numbers. So what I'm going to do, let's go back in here, and I'm going to add another series, but I'm going to keep that independent variable, that x-axis, the same. So if my first series was these three values for the no mask, I'm going to add these three values for cloth mask. Okay. And now, what do we see? So now, oh, I did it wrong. What did I do? I added the independent variable 4 to 6. That's independent variable, so it shouldn't be in the series section. My bad, sorry. I want to add a y value, and diameter breath mark is our y, our dependent variable. So I'll select those. So now, there we go. So something's still not right. Let's make sure this is right. Add our x values and our y values. There's one set of y values, second set of y values. Okay, that's more of what I expected. Because I mean, what you see is that if you track the tops of these bars, these columns, there is an upward trend here, upward trend there. The only reason it's a downward trend here is because now we actually have numbers on the x-axis. And so there's the direction matters now. And now the direction actually represents the way that the data moves. So the whether or not the data increases or decreases. So at this point, I want to have a trend line for the red data as well. So I go back to series. And I could apply a trend line to the blue series or the red series, but I want to apply a trend line to both. And I want there to be an equation for both. Okay. So at this point, our title shouldn't really say that this is only no mask data, because blue represents no mask, but red represents cloth mask, right? And so I'm actually going to change these labels right here. I'm going to keep my slope, so negative 0.893, negative 0.893. And I'm going to say this is blue, so this is no mask. I'm just preserving the slope so that I can refer back to it later. But now you'll see that my label here just changed. So I can do that over here as well. So I'm going to keep my slope negative 0.964, negative 0.964. Oops. And then I want to say this is cloth mask. Slope equals that. Okay. And so at this point, now you can start to see that we're still comparing two variables the same way we did for just no mask data when we just had the blue, right? You could just ignore the red line for now. And it's like we're having no mask data. And then we also have cloth mask data. They both trend downward. So it's almost like we say that now we're able to make the same claim here, or the same title, basically, the same analysis. As the distance of my face from the mirror increases, the diameter of my breath mark decreases, gets smaller. And you don't have to write this, but I'll write it here just so you see. True for no mask and cloth mask. And so my question is, we just put cloth mask on there. So this data, we now actually put it on here, on this other plot. The reason why the direction of the trend changed is because, again, this plot doesn't have X values. This one does. So this was actually like a mirror image, where like this dot right here, or actually this one right here, was plotted over here on the left, 1.5 and 1.5, right? This is 3, and this is 3. So when we put the X values on these, the order of these dots flip to be a mirror image. But the big idea is that we can delete this plot because we just included it on this plot as well. Okay, so now we have two trend lines, two scatter plots essentially. And so the assignment in chemistry class is to have 3. And so you can now work on your own to see if you can include your 3rd variable or your 3rd type of mask on the same scatter plot as a 3rd series of data. Okay, that's what I'm going to say. I hope that was helpful, and I will see you a little bit later.